Applied Materials had a great day. It announced 2 new products, causing its stock price to jump up over 3%. Unfortunately, it does seem like some ASML investors are worried with these new products, which caused ASML's stock price to drop over 2%. But should ASML investors really be worried? Let's take a closer look in today's episode. Alright, so let's take a closer look at the 2 products Applied Materials released. The first one is called Sintura Sculpta, and this is one that helps with pattern shaping technology, which is normally used in the manufacturing process of semiconductors. The second product that they released was the Verity Sem 10, and this is a metrology system that usually helps with making sure yields are great, using measurements, and making sure everything is going okay. So the one that I believe a lot of investors might be worried about, or ASML investors might be a little bit worried about, is the first one I mentioned, the Sintura Sculpta. So now let me try to explain both these products. More importantly, the problem that they're trying to solve. I think once we understand the problem they're trying to solve, we will really see where this hits in the semiconductor market. I want to say Applied Materials presented a nice presentation of 42 slides. And I want to say for any investor, it might get a little techy, but they do share a lot of great information here. For example, here we can see the fabrication equipment side of semiconductors and the different markets that are being hit in this space. Applied Materials also even gave us some of the big players here that are hitting this market. So I definitely would say take a closer look and can really help you understand if you own ASML, if you own Lam Research, CLAC, Applied Materials, where they fall in the manufacturing side. So I definitely recommend this slide right here. So let's take a closer look at how Applied Materials describes this Sintura Sculpta patterning system. They mentioned to help chip makers continue shrinking designs without the added cost, complexity, and energy and material consumption of EUV double patterning, Applied Materials work closely with leading customers to develop the Sintura Sculpta patterning system. So I do want to say that's a lot of words, but luckily in the presentation, they did share exactly what they're doing. So right now, what's happening is EUV, to some extent, even though it's very small, it does have its limitations. So for example, if they are using EUV to create some form of product, EUV can only go so far, and it creates this kind of space, this tip-to-tip space. What happens in the semiconductor market is you want those spaces to be closer. So for those spaces to be closer, what ends up happening is these EUV machines go through a system twice. So they rinse and repeat pretty much. So they do the process once and you are left with this gap. They want that gap smaller. So they repeat the process a second time. And the second time, because they shift things around, they're able to get that tip to tip a little bit closer. And they do mention here, for example, tighter tip to tip spacing enables higher devices density, which optimizes die area. So at the end of the day, what you want is to have that tip to tip closer because it makes this overall chip better. The problem is, like I mentioned, is rinse and repeat. And unfortunately, when it comes to rinse and repeat, it takes a lot of energy, right? Because you have to do the same product twice. The first thing is alignment errors. If you align this incorrectly, you can have a huge yield loss. The second thing is energy and material. The second thing is energy and materials to kind of run this another time, right? So not only can you get alignment errors, you're also using more energy and more materials to run it a second time. And the third thing is you're also using that equipment again, which is slowing you down or kind of increasing the cycle time per wafer being made. So this is the issue, right? There's so many problems that can happen here. So now that we know the problem, let's take a closer look at the solution. So Applied Materials, where now instead of doing the same cycle twice, they do it once, and then you use this new product, and this new product creates an elliptical hole, which reduces that tight spacing. So overall, this is very beneficial, right? Because now a manufacturing company doesn't need to do the same step twice and kind of go through all those errors that are possible. Instead, they only go through the process once, and then they use Applied Materials new product and go on from there. So this overall reduces the overall process loop. It saves design and process complexity. It reduces cycle time. It reduces reduces energy, materials usage, and cost. They even explain how big players can save so much money with this new technology. One of the main things, right? No form of alignment errors here. So I want to say the lithography portion, and if we kind of scroll back up here, the lithography portion is where ASML pretty much rules. This doesn't really get affected much, right? It's just a new solution added after there. So I don't think ASML investors have anything to worry about. If we kind of go back here into the process flow, we can see, right, that the lithography portion is still there. It just releases or reduces the amount of time using that lithography machine. So I don't think this would cost ASML too much, or there's too much fear to be added here, unless you are a huge semiconductor manufacturing company that bought multiple lithography machines just to make this process easier. And if they did have multiple lithography machines to make this easier, now they have an extra lithography machine where they can use it for other purposes instead, and maybe just improve the amount of wafers they kind of come out in the long term of things. So again, I don't think this is bad news for ASML. It's just a way to kind of improve the yield rate and kind of improve a lot of the repetitive task in the manufacturing phase. So if I was an ASML investor, I don't think I would be worried too much, but that's just my thoughts. Maybe some other investors might have a different thought process here. Before we go any further, I want to thank you for watching, and I need your help to reach my goal of 30,000 subscribers by the end of the year. So if you can do me a favor, hit that subscribe button and thumbs up. Also, if you want some fantastic insight into the semiconductor industry, join my other channel, Semiconductor Investing and More, where I use my electrical engineering background to break down the semiconductor market. Finally, I want to thank the Motley Fool for sponsoring this video, and check out fool.com/Jose for the 10 best stocks to buy now. With that link, you get a promotional offer for their subscription service. Now, let's continue with today's episode. Oh, one thing I did forget to mention is they do have some customers and industry comments of this new machine. And it's pretty interesting to note that Samsung, the second largest semiconductor manufacturer in the world, mentioned some good notes. Intel, the one that's really pushing this growth in the manufacturing, also shared some great notes. The only big player that I didn't hear of out of the top three that I have right here is Taiwan Semiconductor. So I thought that was pretty interesting. That might showcase that, hey, maybe this is not a complete usage for all products. So something to keep in mind of that TSM did not make comments on this new product when some of the other big players did. So that's product number one. Again, not much fear for ASML investors. I do want to say I'm becoming a lot more bullish in Applied Materials. Even though I don't own this stock, this is one that I'm regret not having in my portfolio. So maybe if we do see some form of pull down later on, maybe I might start dollar cost averaging. But Applied Materials is looking like a real strong player, especially as we are seeing this huge gain in manufacturing side. I already have huge positions in semiconductor companies. I already have huge exposure to semiconductor ETFs. And I do have exposure through that in Applied Materials. So I understand that my semiconductor companies might move very similar to Applied Materials. And I just want to say, if I get the opportunity, Applied Materials would definitely enter my portfolio. If I don't, I'm going to be okay because I do have plenty of exposure in the semiconductor space. Now, the second product is this e-beam metrology system. And again, let's start off by understanding the problem that's happening here and how this solves it. So here, if we take a closer look at the press release for this new e-beam metrology system, the second product, it kind of explains to us the same thing. It gives us the problem and the solution, and then we're going to take a closer look at the presentation to try to understand a little bit better of what's happening. So they do mention that today they introduced a new e-beam metrology system specifically designed to precisely measure the critical dimensions of semiconductor devices, features patterned with EUV and emerging high NA EUV lithography. The current way that people use, the current method is CDSEMs, which is critical dimension scanning electron microscopes to take sub-nanometer measurements of patterns. Remember, these chips are super small, so you need to have some insane product to measure this. Unfortunately, as products get smaller, the current way to do it is not viable anymore, right? Especially as we continue to get smaller. And the main reason is because these products to measure, they release some form of energy. And because the products are becoming smaller, that energy can actually interact with it and create some form of errors on the chip. So what they need to do is create a new product that produces lower energy but still is able to measure the measurements that they need and not create any errors or kind of have any form of reaction with the product. And this is where we get the Verity SEM10. So here we can see where this metrology is used. It's actually used twice. We can see it's used after development inspection. So after the lithography system is done, you have to kind of check and make sure that everything was done perfectly. The second is after etch inspection, or AEI. Again, it overall kind of helps and understand if everything is inspect. So this metrology system is very, very important. Again, this is more of just solving the issue of what's happening or the problem arising from smaller chips, and Applied Materials is doing it really, really great. So that new products is definitely not something ASML investors should be worried about. So I want to say at the end of the day, this makes me a little, like I mentioned earlier, this makes me a little bit more bullish on Applied Materials. ASML, in my opinion, is still a big player here, but I'm becoming more and more bullish on Applied Materials, even though I don't own. So I just take my time, but Applied Materials is now on the top of my list. I hope you guys enjoyed today's episode. Take care, have a good day, and see you next time.